Hi, welcome to Infer. My name is Eric, and I'm here to give you a quick tour of our amazing platform for enabling businesses to better understand their data and integrate AI into their existing workflows and processes. For this walkthrough, I'm going to use a dataset of 10,000 anonymized bank customers, for which I want to analyze and try to understand churn, and to better understand, what factors drive it and how we can prevent it. Once I've done that, I've got some actionable insights, and I'm going to show you how we can, at the click of a button, operationalize that, how we can use our churn analysis inside our existing workflows, how we can integrate into our existing workflows and into our sales CRM. So let's get started. Okay, let's go. The first thing I'm going to do is I'm going to create a new project in the Infer Insights module. I'm going to call it Bank Customer Churn Analysis, and I've pointed it to my bank customer dataset in my BigQuery instance. So now the project has been created. The first thing that happens when you create an Insights project in Infer is that you're given two options. You can either create it yourself from scratch. That means writing SQL code to fetching data into the data warehouse and writing SQL code to execute and train your model on our GPU cluster. Or you can have Infer analyze your dataset and give you some suggestions, what we call Inspire Me, to the type of analysis that you could be doing. I'm going to have it inspire me. So what it's doing now is analyzing the data, and it comes back with 4 suggestions to analysis that it can be doing. Top one is a customer segmentation. That means it's going to take the 10,000 customers and split them into segments based on their personas, basically. And the next 3 are predictive ones. That's where it's going to train a predictive model to predict a particular attribute of each customer. And then you can use that predictive model, 1, to feed back into your system of reference and operationalize, and 2, to analyze and then get some understanding of the factors in your data that drives these attributes. So I'm going to pick the one at the bottom called Predict Customer Churn, the one I'm after. And click Run. So what it's doing now, it is fetching the data from the data warehouse. It's putting it into our GPU cluster. There it is creating, training, and executing the model to predict churn. It's coming back now. And then once it comes back with the results, it then analyzes the results to give you some insights into the factors that are driving this model. These are the insights into what drives churn in your customer base. So here we have the results come back. There's 3 layers to this result screen. At the bottom, you have the raw output. I'm going to get back to that in a second. In the middle, you have the sort of more detailed insights. And at the top, you have the highlights. The highlights are essentially summaries of all the below, where the platform is analyzing all of the insights that came out below, the more detailed insights, the raw outputs, to give you what it thinks are the main insights to be had in this data. I'm going to start at the middle, the more detailed insights. So here at the top level, we have some summary charts about the model. The one to first look at is the accuracy of the model. Right? Is it worth doing anything with this model? We can see the accuracy of this model is about 82%. It's in the middle of the green zone. That's good. This is a good model. You can continue your work. The next step is then to look at what are the main factors influencing this model. Like what are the things that influence churn basically in your customer base? Here we have all of the input attributes that went into the model, sorted by how important they are to churn, or how much they influence churn. And we can see that number of products bought by customers are about 25%. That means 25% of the customer churns or not in this bank is down to how many products they bought. Age is the second biggest factor. So 21% of the customer churns is down to their age. And then it sort of diminishes slowly down. So age and product number of products they bought makes up only almost half of whether customer churns or not. That's already a pretty decent insight. Probably quite interesting to this bank and their marketing team. Going back, we can then step into the details of that, because the next question is, okay, so age is a big contributor, but how? How is age related to churn? So let's analyze that. So we step into here. This chart has 4 different charts plotting age against probabilities of churn. I'm going to pick the heat map here. In this chart, we see age of each customer plotted on the x-axis and the probability of churn for each customer coming out of the model. Since the model is a highly predictive model with a good accuracy, we know that this is actually explains reality as well. So what we see here is that for the age group 25 to 35, customers are very unlikely to churn, about 10%, so it's a rare event. But as they get older, they become more and more likely to churn, and it tops out at about age 45 to 50, 55 maybe, where they're highly, highly likely to churn. Churn then comes back down again as people get older and they become less and less likely to churn. That's a good insight. That's already something to work on. You can do the same analysis on all the other features. You can produce more of these charts and look into them and get more of an understanding of what are the factors in your data set that drive churn. Now, above that, as I mentioned, there's some highlights. Often people don't even go to the next level down. They'll stay at this level just looking at the highlights. Highlights essentially, as I said, analyze the below charts and giving you the main summaries are coming out. So here it's all sorted by how important they are. So it says the most important insight that we found is the number of products is highly predictive of churn, and there's a very strong relationship between the two. The second most important finding is that age is highly related to churn, and there's a bit of a description here of how churn rate starts low, then goes up, and comes back down. Essentially what we just found, exactly what we just found actually, but automated. So this is how you get quickly to a predictive model, a model that predicts churn and some insights about what drives churn in your customer base. You could do this on anything. I just picked the column churn in my customer data set. I could have predicted any other attribute about my customers, any other attribute about my products, or any other thing that I have in my database. Once you've sort of iterated on that, you found some good insights, there's two things you can do. You can either add your insights to a story. A story is essentially taking this card, putting it into a slide deck that you can share, or you can schedule this, meaning you can put this predictive model on a schedule, have it run every night at 2 a.m. say, and the outputs go back into your system of reference. That be HubSpot or Salesforce, or Klaviyo, or any other system, from where you can then action these predictions. So let me quickly show how that works. So I'm going to create one called Customer Churn Analysis. I'm going to set up this to run every night at 2 a.m. I'm going to put the results back into my Salesforce. I'm going to put them back into the account object in Salesforce. I'm quickly going to map the customer ID to my ID column in Salesforce. And I'm going to map the probability coming out. So that's a number between 0 and 1, where 1 is certain churn, 0 is almost no churn, or certainly no churn. And I'm going to map that to a column that I created called churn risk in Salesforce. So what this is going to do, I'm going to add that. Okay, quick preview. There we go. So what this has done is now created a pipeline that runs every night at 2 a.m. Pulls in all the customer data, analyzes each customer, builds a model, predicts which customers are likely or unlikely to churn, and feeds that back into my Salesforce. And that's how I operationalize it. And that's it. That's the exploration part and the prediction part in Infer. Next time I'll talk a bit about the measure part.